Hello and welcome to the second half of the tutorial on generating live data from your microbit and analysing it in Tony. So in an earlier lesson, what we did was we connected our microbit to the USB connection and we redirected the USB data along the USB to a virtual serial port, and we then read that data into Tony. So you should have already created your make code project called ALT2 generated data to generate the data and redirect it to the USB. And then this data we read into Tony, so you should also have open in Tony two files. One is to find your serial port, which you need to run and check what the current port is on your computer that's being used. So mine is COM3. And then your read serial, which should say COM3 in it. That code, when you run it, should generate the data to the screen. And you should remember from that earlier lesson that the data is coming through as a binary string. So every character in that string is represented using 1 byte. And at the end of the string, we have a character return and a new line showing that we are moving to the next line of our data. So once you have this running, that data is coming into your Python console, but we need to maybe clean that data up a bit and get rid of the B, the quotation marks, the spaces, the \r, \n, those kind of things. So within our while loop, we want to introduce some data cleaning. So the best, or not necessarily the best, but one of the commands you can use is to do a replacement. And if we take an object we don't like or a character we don't want and replace it with nothing, then it will essentially disappear from our code. So at the moment, we're reading in the data that is being generated. And if that data exists, we are printing the entire data out to the screen. So just before we print it out to the screen, I want to manipulate that data. So I want to add a line in here to change the data before we manipulate it out to the screen. So I'm going to bring in a I have it in the wrong place. I actually want to do here before I check the length of it. So after I've changed the data, it might be of length 0 and I don't want to print nothing. So I just want to manipulate it before I check the length of it. So I'm taking the data string that I have and I'm replacing it. I'm using the assignment operator to replace it with the data that used to be there, but I'm replacing something within that data. And first thing I might get rid of is all those spaces. So I'm replacing a space. I'm putting that string of a space within quotation marks, and I want to replace it with nothing. So I have a comma because I'm separating out my parameters, and I want to replace it with nothing. So I have 2 quotation marks here with a space in between, and my second 2 quotation marks have nothing in between. So if I now save that and run that, I should see my spaces from my bit string disappear. Okay, so obviously we want to get rid of the B as well. So I'm just going to add in another line. I'm going to copy this line, add it in underneath, and I want to replace this time the letter B from the byte string with nothing. So again, save and run, and you should see that change happening. So the letter B has gone now from my output. So you should try replacing the quotation marks and also the comma. See how you get on. I'm just going to pause here. If you could pause your video for the moment whilst you do that. Okay, so welcome back. So by now you should have managed to replace everything in your string except for the temperature itself. So like I have here just the number. Now you might note that I have actually replaced the comma as well, though I could have kept that, but for completeness sake I'm just getting rid of everything except for the temperature itself. Remember that the backward slash is actually the escape character. So if I include the backward slash on its own inside a string quotation, the editor, the Python editor, will actually skip over the next character. In this case, I don't want it to skip over backward slash, so I need to include a second backward slash to make sure that it does include it. So the next thing we want to do with our data is not just display it on the screen like this, but we actually want to write it to a file, a comma-separated file. So that is why I could have kept the comma in without deleting it. I can put it back in quite easily if I just hashtag comment out that line. So if I was to save this and run it again, it should be back in. But actually I want to continue with it gone just for completeness sake, just so that you can understand how to progress if it is actually missing from your data in the first place. So instead of printing the data to the screen, we actually want to write to a file. So the first thing we need to do is actually open up a connection to a file. So I have a file command, and I'm going to name my connection file, and I'm going to open it. File itself, I'm naming my temps.csv. It's going to be a comma-separated values file. And I'm going to open it in mode A, or method A, which stands for append. I have options of A, R, or W here. If I made it R, it would be read only, and that's no use because I actually want to write to the file. If I made it a W, I could write to the file, but each time I write, I will be overwriting what's already there. So the A allows me to append to what's already there so that each item is being appended on underneath the previous items. So we open the data file, or the connection, in append mode. We then want to write to that file, or write along that connection. And what we want to write is the data that we just have cleaned up. But we don't want to just write the data, we want to have comma-separated values, so we actually need to also print out or concatenate the data with a comma for comma-separated values. So I'm concatenating with the plus operator the string, which is the comma. So that will be added directly to the data with no spaces in between. I could have put in just a comma here, but that would have added a space between the data and the comma, which I don't want. So I'm using the concatenation operator, which doesn't allow for spaces in between. And remember, after you finish writing or finish using your file, you want to close that connection. So I'm file.close, clean up the collection at the end. So I haven't specified where this file is to be created because it doesn't exist at the moment. So when it does get created, it will be in the same folder where this Python file is stored. So you should have created a folder on your network drive, and this CSV file should end up in the same place. So I'm going to save this and run this. Outwardly, it shouldn't look any different. I'm still printing my data to the screen, so it is still coming out on the screen, but it should also be going to the .csv file. Now it's writing to that file one item at a time, and so far you can see I've only 4 or 5 items on my screen. I'm just going to take up my microbit and heat it up in my hands. So we should see a bit of variation in the numbers coming through. So I don't want to just write the same number over and over and over again to the data file. So I'm looking to see a bit of variation happening here. So I'm heating it up in my hands, blowing on it. On the LED screen itself is where the temperature is sensed. So I have the temperature has risen up there. I'm just going to set the microbit down again and let it cool off. And let the temperature drop back down to the room temperature, which was around 22 degrees. So I'm just waiting for it to cool down a little to 22 degrees. I could leave this running for hours on end. My .csv file would get very long. I don't need that amount of data for this demonstration purposes, so I'm just going to wait till it gets down to 22, and then I will stop the file from running anymore. You might like to maybe take your sensor over closer to a window if you can reach the window. Maybe even put it outside the window, but don't lose it. So you can get a bit of a range in temperatures going on from inside and outside. So just to note that we have currently 3 pieces of code. We have our make code, which is in block form. We also then have our find serial port code, which helped us find the communication port that we were using. And then this piece of code that we've been working on so far today does a number of pieces. It does a number of different things. It sets up a serial connection with the microbit, and then it reads the data that the microbit is sending up, and it cleans that data, and then prints the data out to the screen, and finally prints the data to, or writes the data, sorry, to a comma-separated values file. So my temperature has gone down there to 23 degrees now, I can see. I think that's probably low enough, so I'm going to just stop this code. And I'm going to go and take a look at my .csv file, see how it appears. So if I go to my file, my folder, I have my file created here, my temps. Looks like an Excel file, but if I look at the type of the file, I should see it is a comma-separated values file. So if I just double click on it to open it, it will actually open it in Excel, which will not actually show me the commas between the data. But you can see there I've got a lot of data. Okay, but I can't see the commas between the data. So I'm just going to close down out of Excel for the moment. And I'm going to right click on my temps here instead of double clicking on it. And I want to open it with Notepad++. So I've got edit with Notepad++. So here it's the same data, but we can see now that there are commas between the data. If you go to the very end of your data, you'll see there's actually a comma at the end, which we don't want, but we'll fix that up later. We could just fix it up here just by deleting it, but we can fix that up later when we come to it use our code to fix it. But just to see there, that's what our data looks like. So we can see it went up to 27 there and down to 22, I think it was at the beginning. Okay, so we have managed to take live temperature and upload it to the computer and download it again to a CSV file. The next step in the process is to actually take this CSV file and do some analysis on that data. So at this stage, you can pack up your microbit if it's not needed and put that away safely. So we won't be using that for the rest of this tutorial. So we're going to do our analysis in Tony, using the Tony editor. And we're going to use a brand new file. So if you could create a new file in Tony, and if you save it to your file, so the same folder as all your other files, the ALT2 generated folder. And the name we want to use for this is ALT2 analysis. And remember to add the .py extension to say that it's Python. So currently there is no code here, but this is where we're going to start building our code. So the first thing we want to do is actually open that file that we created. So we want to open a connection to your CSV file. Remember, it was called mytemps.csv. And this time we want to open it for reading, so we need the method R. And remember that you can only read once from a file, so we don't want to read it and instantly forget everything that we read. So we want to read that data into a variable so it's not forgotten. So we're naming my variable data raw or raw data, and I'm reading my entire file into that data, into that variable. And then I can close the connection to the file as I no longer need that connection. So the data will now be read into Python. So I can test if this little piece of code is working so far just by printing that raw data to the screen. So if I save and run, I can see my raw data appearing on the screen there with all the commas. It's hard to see there, but yeah, there we go. There is a comma after the last data reading, just like we saw in Notepad++. Okay, so what we need to do is actually split this data up, because currently that data is all one piece of information. It's being read in as one big long string. So basically we want to split it up into a lot of different strings using that comma as the separator. So I'm going to add in a line which will split it up. On my data raw, I'm going to I'm going to keep this my data clean. I'm going to call it. I take my data raw and split it using that comma as the character for splitting it with. So I'm keeping my data raw unchanged just in case I mess things up and I won't need to go back to it. I don't need to be reading in the file every time. So if I now stop this, save it and run, the data is being printed out to the screen, and it is exactly the same, or it looks exactly the same as previously, but it is actually being printed out. Sorry, it does look exactly the same, and the reason why is because I've printed out the data. Well, I want to print out the clean data this time. Okay, so try this again. Okay, so the clean data now is being written out. You can see that we have still got the commas, but these commas now are in a list. So we have our list, we have a square bracket at the beginning and end, and our numbers are 22, 26, 27. They are as strings, so they have quotation marks around them. They're stored as strings within a list. So we don't actually want them to be stored as strings. What we would like them to be is stored as numbers, maybe point numbers or integers. It doesn't really matter, but I'm going to store them as integers. Or sorry, I'm going to store them as strings. So my data clean this time, I want to adjust it to be, go through that list one by one and turn each of those strings that are in it into an integer, or a floating point number, sorry. So I'm going to take the list, I'm going to create a new list, and in that list I'm going to put the data that I did have. I'm going to go through that, each item in it. Okay, so I'm going to go through each item in data clean. Sorry, I'm confusing it. I want to take each item in data clean and turn it into a floating point number, and put all of those items into a new list, and take that new list and put it back into data clean. So I'm overwriting data clean with this new list that I'm creating. So when I try to run this, I will actually get an error message. We'll see that now. This is why it's important to test at every point. Every time you add a new line of code, you should be testing. And you can see I have an error message here, which is a value error, which says it could not convert a string to a float. So there's one of those items in the list that was a string that it couldn't turn into a floating point number. So I'm just going to take that code out that I just put in. I'm just going to comment it out for the moment and run the code again just to have a look at our list. And we can see that that item at the end of the list has actually been made into an empty string. And it's impossible to turn an empty string to a floating point number. And that's where the problem came in. So what we actually need to do is to use the whole of the list that we began with, except for that last item. So here where we split the list, before we split the list, we actually want to drop the last item off the list. So I'm going to adjust my data raw to be the data raw indexed. And the index will have everything up to and excluding, sorry, the last one on the list. So -1 being the last one when we're counting backwards. So that should remove the last item from the list, and then we should be able to split the list correctly. So we'll test that much, and hopefully we'll see the empty string at the end disappear. There we go. So the empty string at the end has gone from our list. So now if we bring back our float conversion, casting, hopefully it should work now without an error message. Okay, so we have no error messages, but they kind of still look like strings. So what I want to do now is to analyze some of this data, use some statistics, so find the minimum, find the maximum, that type of idea. So at the top of my code, I need to import the statistics module. So at the very top of the code, I'm importing statistics module. I'm just going to save that and run that to make sure there's no issues with the importing. Okay, I have a warning over here, but it's just telling me that I haven't used that statistics module yet. But it's just a warning and not an error, so that's okay. So now, rather than print out all the data to the screen, I'm going to print out maybe the minimum of the data to the screen. So minimum data clean. So let's see how that works. We can see the minimum is 22. It's going to get very confusing throughout the script if I keep referring to data raw and data clean. So at the point where I have decided that my data is now totally clean, I can transfer all that data into a new variable just called data itself. So in future, after this point, I just refer to data rather than data clean. If I decide at any point to go back and do some more cleaning, I would include it in this section of my code. So what would be good practice is to add in some commentary. So here we are reading in the raw data from the CSV file. Remember that a file can only be read once. Okay, some commentary down here. Here we are cleaning raw data. Now the data is cleaned. Okay, so this next section is where I calculate my statistics. So calculating some statistics. So the first thing that I looked at there was min data. So the min of the data now. But I don't just want to find out what the min of the data is. I actually want to remember what it is. So I'm going to put in a new variable called min value. And I'm going to have also the max value. Well, min and max are actually part of the built-in library, so we're still not actually using the statistics library at this point. We can just use the built-in standard library for those. So I want to calculate the mean value or the average. So the mean is going to be the sum of all the data when we add them all up, divided by the length of the data. So how many pieces of data do we have? Once we add them all up, divide it by the number we have, and we get our mean. Now, possibly we want to be testing, is the temperature in this room suitable? So there might be a minimum value that's allowed for the temperature. So the minimum temperature allowed, I'm going to set that to 17.2. And this is partly why I have a floating data rather than just an integer. And then I don't want it to get too hot, so I'm going to put it to the max allowed as well. And let's say the max allowed is 26. So I'm setting those as variables. In fact, they are constants, so it would be more normal to use not camel case, but capital letters. and not spaces, but underscores. That indicates that these are actually constants. They're not expected to change throughout the code. Okay. And this section down here is printing out or displaying results. So the first thing I want to display is my min value. Oh, I don't want to just display the min value on its own. I want to display it as with a bit of context around it, explaining what it is. So I'm putting in a string here. This is my min value, and I'm following that with my min value. And then I'm going to do the same for the max. I'm going to print out here the range that my data spans. So what's the difference between the minimum and the maximum? So the range is the value subtract the min value. So note that I'm actually calculating the range on the fly here. It won't be remembered, it won't be stored. I could have put a variable up here called range and stored that value and then printed the range value that I calculated. I also want to print the mean. I'm going to print the mode, so which value occurs the most often. And for this, I'm going to use the statistics library to calculate the mode from my data. And similarly, I'm going to use the median, which one's in the middle, when I put them all in order. And again, I'll use the statistics for that. And then finally, I'm going to print the allowed values, the minimum allowed. And similarly, the maximum allowed. So let's save that and run that to see. Okay, so I've got an error, a name error. I'm using dat clean rather than data clean. So this is on line 14 of my code. So I'll go back to line 14 to see where I made the mistake. Okay, here we go. I'll fix that. Save and run again. So now I have a type error. I'm adding integers to strings. I've got to concatenate integers to strings, and that is happening in line 19. So my data is still being stored as a string. So I need to sort that problem. Okay, I have discovered the problem in my Python code. It's on line 12, and it's just a typing error. Data clean here, this data clean has got a capital L when it shouldn't have, should be a lowercase l. That was all the issue should be. Okay, so we can see there now our numbers are floating point numbers, and we have our output. So our minimum, our maximum, the range, the mean temperature with all its decimal places, mode, the median, the minimum, and the maximum allowed.